Hey everyone, it's Sloppy Joe Pirates with another Writeup video. Today I'm going to be talking about TetCTF2023. This was a two-day CTF hosted January 1st to January 2nd. Overall, a lot of fun challenges. So I'm going to be talking about these challenges: New Year Bot, Image Service Viewer, Gift, TetCTFToken, Casino, and Casino 2. So let's get started. The first challenge was New Year Bot. It says, Happy New Year, my friend decided to learn to code in the new year. Here's his very first website. It's very secure, user input, and we're given the source code. So we can kind of tell this is going to be a bypassing some sort of filtering challenge. We get some website, New Year quotes. We can ask it a couple different questions. We can look at the network tab too. So we make a request. Not much going on. Let's do this one. We'll ask it. So we're making a post request. And we're making it with a type and a number, so a list and a number, cool. And it brings us just a new quote. Cool, so we were given source code, so let's take a look at that. Already have it downloaded. It looks like it's just a Flask app. We already have the flag loaded in, so it looks like somehow we're gonna have to bypass validation and get back the flag variable. We have random greeting, some sort of validator, one route, and that's the only route. Cool, so we have one route. It's going to return some HTML, nothing too exciting. And here is our inputs. So we saw in that request there was a type and a number. Looks like there's also a debug parameter we can play with. And what else do we have? If it's a greeting, it'll pick a random greeting. If not, it looks like it's going to generate a greeting, and it'll return some HTML down here with CSS font, body, and greeting. So it looks like the output of all this is going to be this greeting variable, and somehow we need to put the flag in this greeting variable. We can see an eval here, which looks interesting. It's taking two things, greet type and greet number, which are input. So it seems like we kind of know what we need to do. We have a source and we have a sink. And so presumably in here, there's going to be a bunch of validation that we need to bypass. Looking at the top again, we saw that there was a flag variable. So we have flag with a 4. So ideally, we want this to be flag, and this would be something like that. So let's see what we can do. Greet type, it only has to be an identifier, which is just a Python variable, like the same rules as Python variables, so letters, numbers, underscore. So that's easy to bypass. There's nothing really. There's going to be a length check, so our total eval string has to be under 20 characters. But otherwise, it looks like we can just pass flag as greet type. So that one's easy. Then we have greet number. Actually, we can just try this so far, what we have. So this is the website. So what this code is doing is it's going to the website. Here, it's putting in that payload. We're just doing a request. And then it's filtering out the single character that we should get. Oops, not that one. And so if we run this, pi3, oops. We can see we get back a single letter T. Let me make that bigger. Cool. So this seems like it would be pretty simple. So we got the first character. We can try getting the second character, and the third character, and the fourth character. But we'll find out once we get to, I think it's 7, we get back this instead. So it looks like some sort of validation is happening. And so if we look a little bit more at this greet number, we can see that all the spaces, or the white space characters, will be removed. And also there's the length check, and there's this bot validator check. So let's take a look at bot validator. Numbers only. It's going to do some checking from 57 to 123. Right off the bat, that includes more than just numbers. This is probably the start of numbers, or the end of numbers. So we're allowed to use anything under 57 or above 123. Then it's going to find all numbers in the string we pass it. It's going to double check that it's a numeric number, and then it's going to check the maximum between our number and the maximum of the categories list. So it's going to go through all of these and see which one has the longest length. And so basically we can type in input. What we have is we can type in input as long as it's only these characters. So we could type in this. It's going to create a new string. Let's say we had something like this, but it's going to create a new string here. So instead this will look like 78367, and it's going to make sure that this is less than, this number has to be less than 6. which is tricky. So we can't do something like this because this is like if we're to do 1 plus 1, when we strip out all characters except for numbers, we're going to be left with 11. So that means we can generate something like this, a bunch of numbers. It's allowed to have a bunch of zeros at the start because this will always be less than 6 or 5, something like this. And we're allowed to use any ASCII character below 57 or above 123. So if we look at an ASCII table, we can see we have, what did I say, 57 is where it starts. So yeah, we have numbers, so anything below. So we have a couple different operators like plus, minus, divide, but since our number has to start with 0, those don't help too much. But eventually we saw that we're allowed to do above 123. So the interesting one is this tilde. So this is a bitwise not character. And so what you can start doing is, if we look at like tilde 1 is -2, and we're allowed to use minus signs. So something like this will generate the number 2. And so using this trick with the tildes and minus signs, we can actually build up all numbers that we need. And so the actual solution, there's a very cool way that someone else did. I'll talk about at the end, but this is the way I solved it. I just kind of use these bitwise numbers and minus signs to just kind of construct every number that was needed. And so you can see I can go from 0, 1, 2, 3, 4, 5, and then this will generate a 6. I call it payload 6, and then a 7, 8, and then this is how I generate -10, -9, -8, and then all the way back down. And so if you run this script, hopefully it's still working, Python3 solve.py, it'll just make the request and generate all the characters, and you'll get the flag. On Discord, someone did something very cool. They did a, actually, let me see if I can find it. Web. Where is it? Oh, yeah, this one. Yeah, they used Unicode characters, and so you can do slice in RE, and so I guess this passes the filter because those characters are above the limit, but they still get executed as valid Python, so way simpler solution. But anyways, the next challenge was image service viewer. Do you know which secret on my server? We're given this and the binary. Cool. So let's take a look. So we have something that'll grab images. Take a look at the source code. Not too much going on. It just looks like a single form. We're given a placeholder, a bunch of CSS, an on submit post get image handler, and it embeds the image. So not too much. Let's take a look at the files that were given. So it was, what's it called? Image service viewer. So we're given a Docker container with a bunch of setup instructions. This container, or this compose file, is used by a couple different challenges. There's the image service challenge, and then there's also this admin portal. We don't actually need the admin portal, but there's I think it was a Java deserialization using LifeRay, but I didn't do that challenge. So instead, we're going to only focus on the image service. There's also Nginx, but I don't think it's important for this challenge. So we're given this image service container. We can see that there's some Node.js and some Python. This was mine, that was mine. There's a flag, so a flag on disk already, and we can see it'll be here, flag TetCTF. So if we look at this, this is our website, Node.js. It's always nice when it's extended, so that we're probably going to be doing some the Node.js QS package, some shenanigans with that. Ignore that. We have an admin check. If rec query password.length, rec query password not equal. So they give us the password, but this is a little bit tricky because this password is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters, and the password is not allowed to be above 13. But thankfully, like I said, the query string parsing is pretty flexible, so you can do something like password. Oops. Well, actually, we're doing two different tricks. First, you can do password 0 is equal to this, and password 1 equals blah. And so this will pass an array, and so this array arrays and strings both have length. So by default, this will work. This will be length 2, so it's not greater than 12. And what's cool is, let's do Node.js. Ooh, do I have Node? ABC of an array is equal to ABC. So, and I think you can do, maybe you just want an array. Oops, my bad. So let's just do this. Cool, so if we have a single array with a single element, it'll be true to its string counterpart. So that's how we can bypass this isAdmin check. So first bypass. There's also this validate function. So this looks like more Node.js middleware. We're given rec.res next, so yeah, it is middleware. We're only allowed to use strings and numbers. Not sure how that actually worked, but anyways, I don't think that was actually used then, because I used the array trick. Anyways, then we have API get image. We can see it's going to take a URL parameter. It's going to check if it's a valid protocol, check if it's a valid host. And if it's a valid host, it's going to download the image. Valid protocol, it's going to parse it and make sure that it's part of HTTP or HTTPS. Not bad. And is valid host, it's going to parse it again using a different parser. And it's going to see if it has the host i.ibb.co. And then we also have this WAF. And then if it passes all those checks, it'll download the image. So we have a spawn call, Python, bot, and the URL. Cool. So somehow we need to, there's going to be some mismatch between the parsers that'll allow us to have a fake host or a fake protocol of some sort. If we look at bot.py, we have a local file adapter. So this seems like how we're going to be able to read the file. Somehow we need to trick the bot.py into reading the local file. If you compare this comment, you can see the code is the exact same, so nothing fancy was done with this. It's just reading how to read a file off disk. I think one thing the comments are interesting is return, should I bother filling in? No. Oh, I think there was a comment about how it only works on, oh yeah, to do properly handle non-empty hostname portions. So this only reads path, so it'll ignore the hostname, which could be useful. Anyways, we keep looking. So we mount to the file adapter. So if we specify the scheme as file // we can read the file or read the flag off disk. But what gets tricky is while list extension, it's going to validate that the URL ends with one of these, but that's easy to bypass. You can just do a comment character and then JPEG, or sorry, a hash symbol in the URL. It's called fragment identifier in the URL, and anything after that will be ignored. Technically, you're not supposed to send these to the server, but you can, and the server will ignore it. If valid extension, it's going to make a head request and make sure that this is in, the content type is an image. So that's pretty tricky because the file isn't going to return a content type. So if we look here, there's, I think if you do a response dot, you can kind of see if any headers are being set. You can see reason, status code, raw status code, URL. There's no headers being sent. So this doesn't seem possible. And so, but if it passes this check, then I'll do a get request and it'll send back the contents. Cool. So we have a bunch of different validations to bypass. This one is easy. I already knew about this one because this was a bug I encountered while just doing some normal programming with the request library. So request will by default follow redirects. And so what that means is we could set up a web server and we'll have it do a request.head. It'll do this request and we'll send back a valid image with the content type, everything correct. And then when it does a get request, we'll actually do a 302 and we'll redirect it to the file handler. So we'll have a valid request that'll pass a bunch of the checks like, I don't know, attacker endpoint. And we needed it to end in, something like this. What we'll do is our attacker endpoint will then do a 302 redirect to file flag.txt or wherever the location was. And request will just implicitly follow that redirect and then load the file for us. So first we respond with a fake head and then we do the redirect. So we can bypass most of this logic without too much issue. So the only thing that we're really stuck with then is bypassing this check. So we want to have it return, we want parse.host to return this, but we want Python to go to our attacker host. Thankfully, there's a bunch of issues in this package. If you Google around, you'll find a pretty well-known exploit. Let's see if I have it somewhere. Oh, this is the, yeah, this is it. So if you do Node.js, that library, if you were to pass it this, it'll say that the host is this one. But if you look at Python, Python will say this is the host. And so this is kind of how you can trick the difference too. So this will pass the host check, and this will actually be the request that Python makes. And so this is the attacker server. Like I said, we're going to have two different routes. One that's going to do the head request, and it'll return just an empty response and the content type, and it'll have the image word in it. And then when it actually makes the real GET request, we'll just redirect to the file. So overall, pretty neat. A lot of just neat bypassing of the different URL types and the redirect. The next challenge was called Gift. 14 people solved it. Did you have a difficult year? Here's a free point for you in the new year. PS, don't automatic scan. I have give you everything you need. We're given a server and a file. So let's take a look. I have it loaded here in Burp. So we have TetCTF, we have a couple of links, one login, forget your password. We can see all of these URLs don't really go to anything. If we took a look at the page source, not too much going on. We have some CSS, login register, which were fake. And down here we have a URL that says sendpic. So one thing to keep in mind here is, so we have username, password, and access key. I assume that's supposed to be access key, not access key. With this access key will be important later. But anyways, let's go take a look at this sendpic thing. We're given a URL and an ID. We can take a look at the page source again. Looks pretty much the same, no hidden messages. So just a URL and an ID. So not really sure what to do at this point. Let's take a look at the file they gave us. So they gave us a file called gift.sql. It's a MySQL dump. And it looks like there are two tables. There's access key and pictures. The access key has ID and key CC. And pictures has ID and URL. There's one entry in the access key table and two in the pictures table. If we look at the access key, this is probably the access key that the login form was talking about. We can see it has ID of 2 and a value of censored. And so this is probably the value we want to get. Here we have pictures. We have two pictures, one with an ID of 1, ID of 2, example.com, and localhost. Cool, knowing that, we can play in here and try to get something. So we can type in a webhook URL. Is that this one? Ignoring that, 845, yep. We'll do that. And if we give it an ID of 1, we'll notice we'll get a webhook here with example.com. I'm not really sure what this is supposed to be emulating. It's strange to give it a URL and then it'll give you a URL in response, but that's what we have here. So we have our webhook. Like I said, we gave it an ID of 0 and we got back example.com. Or sorry, we gave it an ID of 1 and we got example.com. And if we try 2, hopefully we get Mezzi. So let's try it again. Webhook 2. I think this is appending something. And here, hopefully we get something with Mezzi. And we do. Okay, so it looks like the ID parameter is being loaded from the database and URL is where our request is being sent. So loading this into Burp. Oh, I already have the solution here, but let's delete this. So we can test to make sure everything's working. So this is just this request in Burp. We can see that we're sending the URL and an ID parameter. We get back the thing. We can test that it's a SQL injection. There's a bunch of different things you can do, but we can do 2 - 1 and then comment character. And we see we get ID 1. All right, so we have SQL injection and we're interested in a value in access key. So we can start doing a union injection. So we can do an ID that doesn't exist, such as 5. We'll do a union, select. Let's start with ID from, I think it was access key plus limit 1. And let's see what we get. Cool, so we get a ID of 2. If we look at our access key table, we can see, yep, there's only one record with ID of 2. And so now we just need to grab the censored value, which is in this field. So we're going to do select key CC from access key limit 1. So nothing happens. Eventually you'll find out that there is it's filtering on this value. And so your request, either you don't actually know what's going on, there's no source. So either maybe it's seeing key CC and filtering on that, or maybe it's seeing like a flag, for example, in the response, and this is the end of the challenge. And so if it sees flag in the response, it'll also cancel. So I played a while with this. I tried loading character by character. I tried to see what the filter was doing. You're not allowed to use parentheses. If you were allowed to use parentheses, you could get rid of this. And there's a trick, I think it's like this. Select F1 from select, I forget something like this from table. There's some syntax where you can do like this, where you can select a column without actually putting in the column's name. I forget the exact syntax, but you're not allowed to use parenthesis characters in the SQL injection, which makes things a lot more difficult. After a lot of playing, I found out that for some reason they were just doing a lowercase compare, and so you can just do uppercase characters, and you'll get back the access key. I'm not really sure how real world this is. I think if people are smart enough if they know there's a SQL injection and they're going to do filter characters, do you think that they would do a dot to lower first? But a little bit frustrating, waste of an hour or two. But eventually we get back this access key. So we get messy is go, and we can use this to log in. So let's copy that. Let's go back to the index page. Admin, we'll type in our access key. Remember me, why not? So we log in, and we have a new page. There's not much going on. Let's look at the page source. Not much going on here. Index.php. There's nothing, do not look. There's main. These are interesting. Both of these aren't found. There's a lot of red herrings in this CTF challenge. I thought these were going to be important later, but they weren't. There's also some Perl, a PURL. It doesn't look like there's much. Luckily, I was looking at this in burp. Otherwise, I probably would have missed this. There's some JavaScript way over here that says get image.php file.messy. So this looks extremely suspicious. So let's take a look at that. And we can see it is loading this file. So obviously, first thing we do is we check for directory traversal. And we can see we have directory traversal. Or so I thought. So at this point, you do your normal stuff, you see what else exists on the box, you try to load other things. What would be nice would be something like this. We can start leaking values. We get back a blank response. And we get back blank responses for a lot of different things. And if you keep playing with it, there's just a lot of weird stuff that is going on here. For example, this obviously does not exist, but we still get a response. And if you start typing in weird stuff, we do get an error message. So and it has a lot of good information. So media has failed to open stream. We can see this is the requesting file, so we know where we are. We know it's starting with a media, and it's a include statement. We also know where some of the PHP code is located. So very useful error message, but everything just doesn't quite make sense. Like, why are we getting blank responses? What's going on? Eventually, I started fuzzing here just to see what else. In Discord, they were talking about you have to do some light fuzzing. So I started looking around. Anything with session.php, you get a please hack me. And eventually you find out it's actually just ses that says please hack me. And so there's a well-known PHP exploit where PHP creates files on disk for your session. So if we look at document.cookie, my PHP session is this. And so if it's using the file storage method for cookies, it means there's a file on disk. It could be like here. That'll contain a PHP serialized payload of things related to my session. So it could be like my username, my ID, my roles, stuff like that. And so the fact that it says please hack me, it filters on sesh. I mean, it's just like screaming that you need to exploit the session file. And so that's what I tried to do. I spent maybe 12 hours on this challenge, generating a huge session list file. from all the different possible session locations. I even figured out you get some response headers from the server. Laptop's getting slow. You get some response headers, so we got PHP 3.337, Apache 2.452, Debian. You can find a Docker image that looks like it is this exact server. I went onto that box, I looked at all the PHP ini flags, or sorry, files, to try to figure out what the default location would be. And I just started scanning over and over for all of them. I tried, different sessions, and I just couldn't get anywhere with this. Sadly, I did not solve this challenge. I tried loading the PHP ini files to see if we could maybe, get some information about where this session file would be saved, because the challenge author is telling us that we need to exploit that. And what's also strange, if you play with it more, you'll find that if you do like lib php ini, it says don't hack, which to me means like the challenge author is saying that we're supposed to stick with the session stuff. We're not supposed to do this. So I didn't solve the challenge. I found out in Discord after the challenge ended that we were actually supposed to go down this path and try to get raw command execution, not just read the session file. So very frustrating. The solution, again, I didn't solve it. Someone else in Discord wrote out the solution. You were supposed to abuse this. This is the actual payload. There's two payloads. First one is this peckle command.php. So the backend server was doing a couple of things. First off, it was filtering on, if you do .. /.. it would filter that out. So you either need to do .. // or .. // Both of those would work. You're supposed to use this file. Normally for this type of exploit, people use a file called paircommand.php. This is used for installing PHP packages. But you can use it to, if you have a local file inclusion, you can use this to get remote code execution. The challenge author is scanning for, I think, for this exact file, and so you just have to put an extra character in there. Again, just doing string comparisons. But from there, you can basically install a fake package. So this one's just to do a get command handler. We're going to put it into a temp directory, and to make peckle command.php happy, you just have to add some extra stuff. So it's the command line argument. So config, create, and then this. Once it's there, you can start calling this PHP shell. So here we're doing ls root with the file, the backdoor, and you can see there's a file in there called flag.knee-hi-hi.txt, and then you can just cat it out and you'll get the flag. The next challenge is TetCTFToken. I didn't solve this one either, but I just felt the solution was so cool, I just want to talk about it. We're given a server and a binary, so we have the source code. And there's a couple of notes. So we have something cool for you. We hope you enjoy it. And there's a protection mechanism for the team that already solved the challenge. You don't have to do anything. And it says token. So it seems like some sort of cryptocurrency challenge. The token will go to the moon, bunch of memes. We can sign in, sign up, forgot password. If we look at the source, I don't think there's too much exciting stuff going on. We can try to register, but when we register, it actually says that we're not allowed to create an account. We're given source code, so we can look around. We can see it's a Flask app. We got an app.py. There's a bunch of stuff. There's a SQL database. There's a WAF, secret key, some default usernames. We can see an RPC URL. So it is a real sort of cryptocurrency challenge. It has the API and the address. So that's interesting. This is BSC testnet. So it looks like there's a real contract out there somewhere that we're going to have to exploit somehow. Some flags. It looks like we can buy the flag. So maybe if we have enough coins on this testnet, we can buy the flag. There's a dashboard, sign in, show up, forgot user password, log out. Secret token type, this is interesting. So it's just reflecting. So this would be nice if we were doing like a CSP challenge where we have an arbitrary code reflection. Or if we're going to do service workers, it's another thing where it's nice to have a reflected content. There's a trigger reset password. It takes a username. We'll look at that later. Proof that Tony Stark has a heart. It's just generating some characters from a UUID. We're validating some proof of work. So we have to do some MD5 hashing, the first 5 characters. That's easy enough. Some strange parse function that just takes in a URL, calls curl, and doesn't do anything with it, just curls out to some URL. It'll check if a flag is claimed. So I guess this is how we do the validation to buy the flag. So it's going to do W3. connect to the RPC URL. It's going to interact with the contract based on the address and the ABI. It's going to call a function called flag claimed on an address. That's interesting. And it's going to check flag claimable on smart contract username. So it's going to check if flag is claimed on a username. So it's not actually an address, it's a username. So it's going to see if the username has claimed a flag. And it looks like that is how we get it. So we need this smart contract function to return true for a username we control. Cool. There's also a signup function. So if you validate login and by flag, just kind of skipping ahead. So there's two parts to this challenge. One, we have to do the smart contract part of it, where we need to get a flag. Sorry, we need to get enough coins so that we can buy a flag. There's also the second part, which is actually getting into the web app. I kind of want to talk about getting into the web app because this is what I was actually stuck on. But actually, if we talk about the smart contract first, I didn't solve this part. I didn't solve either parts. But this is someone else on Discord. I forget who sent this. They posted this solution. So it looks like it's just a reentrancy attack. So let's look at the smart contract. It wasn't included, but you can just go to, if you actually look at the code. So we go back to dashboard. They give us two links to the flag contract and the token. And so if you go from there, you go to this address, eventually you'll be able to download the code and look at the contract. So the contract isn't too bad itself. There's a lot included in here. Our interesting stuff is at the very bottom. So this is what's actually interesting. So there's a flag store, it's guarded, there's a flag price, so it costs 1337 times a bunch. There's a mapping to see who's claimed the flag. There's some special TET token. We look at the token, it's an ERC20 token. There's nothing too special about this. You can both mint, burn, but only the owner can do this. So very generic token. The owner can set a flag price. You can deposit. So it's a payable function, which means that you can send it Ethereum or whatever the underlying coin is on this network. Things like BNB or BSC or something like that. You can send it values and it'll mint that many tokens. Cool. You can withdraw, non-reentrant. So we can send it tokens of one type and then withdraw tokens that we like. That's interesting. What's very interesting is this message sender.call. So it'll send us tokens in this call function. And that's where the actual exploit is. And then once we're done, we can buy a flag. Address sender, it'll make sure it's not a contract, so it's a real address. There's no code there. And require balance to make sure we have enough to buy the flag. If so, it'll burn those flags and it'll say flag claimed equals true. Cool. So, like I said, I didn't actually exploit this. This is the solution someone else posted. This NTC. They created a new contract, TetCTF2023 solver, the flag store contract, and you can see that they're doing a reentrancy attack. So they're going to deposit a value and then withdraw, and this is a payable function. And so anytime that they call pay on this function, it'll go back and try to withdraw those funds over and over and over. A fairly common sort of attack on these types of challenges. So whenever this calls, so you can see they check to make sure you have a balance, and then they're going to call back to your contract. And so what you can do at this point, really they should have checked to make sure message sender.code length, that check should have been here. There's probably other guards against reentrancy. But so when this function is called, then you can call back and withdraw again and just withdraw a whole bunch of values until you have enough values, and then it'll burn everything. But by that point, they've already given you all the tokens that you need. So fun challenge. So that was the blockchain part of it, or sorry, the cryptocurrency part of it. Then there was another challenge, which frustratingly I did not solve during the CTF either. Someone else had to help me afterwards. I forget who wrote the solution. I think it was Strelic. Yep, Strelic ended up explaining to it. It's a cool bug. So, like I said, you're not actually able to log into the website because it says we are in a private token sale phase, so you cannot log in at the moment. There's a lot of different things I checked trying to log in. So you can sign up, you can validate, you can try to log in. There's a password reset, and so I tried all the normal stuff. Like there's no secret key isn't leaked, so you can't just make a fake session. There's no database injection. It's using parameterized queries. You can actually see what all the queries are. There's just no injections anywhere. It's a little bit strange that they have both usernames and emails, so I thought maybe you could kind of confuse one, but there's nothing there. There's this admin, there's default accounts. Maybe you could like take over one of those accounts, because there was a hint about like resetting based off of previous users solved. So like maybe you compromise one of these and then you can solve it. Again, I spent quite a few hours just going through everything. There was one thing that was just super weird though was, so this is the password reset call code. What'll happen is it'll generate a fake password for you, just a UUID, and it'll set that as your password in the database. But then it generates the secret reset password URL for the gen token route with the secret token. And what's weird is gen token, if you look at it, where is it? It just reflects the content. So what I thought this bug was going to be was then you need to find the access logs, and if you can find the URL that this token is sitting, then you have your reset password and you can log in. But that wasn't it either, and this was just so strange because it's making a curl call. This parse function is the curl call. It just curls out to this URL that has your password in it. Anyways, like I said, I think it was Strelic ended up telling me what the solution was on Discord, and it's this external call. So the server doesn't actually know what its host name is, and so what it'll do is it'll actually read the host from the HTTP host file on the request that made it. So you can just send an attacker controlled host, and when it does external true, it'll say that it thinks that the full URL is that one in the host header, and so you just do an attacker controlled one and you'll get the response. I'm kind of disappointed in myself that I didn't see this one. Now that I see it, it just makes so much sense that this external true call, I just figured that somehow it would know what the host name is, but there's nothing here. And I should have guessed too that it was connecting over IP address, which is also kind of a little bit of a hint. I guess not really. I mean, I guess it could still be the IP address, but anyways, yeah, that was the trick. You were just supposed to send a host header with something you control, and then when it generates this full URL, it'll read it from the host header, and it'll send the password to your endpoint. So cool attack. And then so from there, you're able to log in, and then you can actually start the real cryptocurrency attack. But this was the web portion of it. Anyways, cool challenge. Learned something new. Definitely I'll look for that in the future. The next challenge is Casino. This was a crypto challenge, although it says not really crypto. It had a whole bunch of solves and a file to download. So if we take a look at the source code, we are given this Docker container. It has a main.go, flag seller, Docker file, casino, and the flag. So taking a look, actually if you netcat to the service, nothing exciting happens, so you really have to look at the source code first. We can see we have this request structure, recipient, command, username, amount, and balance. The challenge was called casino, so we can guess that there's probably going to be some betting, and it looks like we can buy the flag from flag seller. Cool, it's going to read the flag, it's going to create a new casino, it's going to create something called a flag seller, which we'll look at a bit, and then it's just going to read lines from standard in. This is most likely, if you look at the Docker file, that's going over SOCAT, so it's going to read over network. But read from standard in, it's going to unmarshal line by line, and that's going to be a JSON unmarshal, so we're just going to send it JSON blobs. And then depending on the contents of the JSON blob, it's going to either going to go to the casino or flag handler, depending on the recipient, and then it's going to do all the different commands. So our end goal is probably to get enough money so that we can interact with the flag seller. So if we look at flag seller, they're given the flag, and there's a function called print flag. It's going to take a username and a balance and something called a proof, which is interesting. So there's something called an IAVL, which we'll have to look at. We actually don't need it for this challenge, but we're going to look at it a lot in the next challenge. The code for this challenge and Casino 2 are pretty much the same. But it's going to do some sort of verification, and then it's going to look at the balance. So off the bat, we can kind of guess that we're going to supply a username. So our username, we're going to say what that balance is, and somehow it's going to verify that the username and balance actually match. And if they do match, it's going to do balance.bitlength divided by 8. And so for every byte of balance we have, we get a part of the flag. And so if we only had 1 byte of balance, we would only get 1 byte of the flag. So a little bit interesting. And so to make money, register, probably not there. Show balance with proof. This is probably how we get the stuff that we can send to the print flag function. And so all we're left with is bet. So this is part of the casino. We're going to give it a username, an amount, and a N, which is probably our guess. So let's take a look at casino. So we have the casino file, generates a casino. Looks like it's using crypto RAM, 8 bytes. So we're probably not going to be brute forcing. Well, it's going to do a ran.seed. So it's possible that we could try to predict the outcome of math.rand since they're not using a crypto rand. So something to keep in mind. There's a get balance function, username. It's reading off this tree structure, which is a little strange. Set balance. So obviously we would like this to be a large number with our username. We can register new characters. It looks like we can only create so many characters, so there's probably no like coalescing of funds together sort of attack. And it looks like we probably just can't create a billion accounts and just try to bet the maximum amount every time. Then we have bet. So this is our actual bet function. So this is probably where the bug is going to lie then. So we're given a username. We're going to get, we give it a username, an amount we would like to bet, and some integer n. It's going to check our balance. It's going to make sure we have enough balance. Right off the bat, this is pretty interesting. It's just going to check that we have more than the amount that we're betting. And so it looks like there's a bug here. So we could pass a minus value, and a minus value is always less than the current balance. So that's one idea. It's going to do r is equal to some random number, and if rn matches a random number between 0 and 2023, we are going to multiply our amount by some big int. Cool. And then it's going to take that reward, it's going to add it to our current balance, and set the balance, and it says, congrats, you won the balance. Cool, otherwise we lose. Most likely we're going to lose, so this is probably the path we'd be interested in. So it's going to subtract our current balance and the amount we bet. So if we subtract a negative value, that's just adding a positive value. So it'll add that to our balance. Cool, so it seems like we have an exploit. We can just pass a very large minus value as the amount we want to bet, and assuming we don't win, there's only a 1 in 2,000 chance we win, it'll actually subtract a huge value from us. We need to send it some proof, and so this is that proof function, so it'll give us a proof object for a username. So we give it a username, there's some tree structure that it's grabbing the proof from, and it just returns it to us with base64. For this challenge, we don't actually have to know what this is, we just pass it to the end server. So with all that in mind, the solution shouldn't be too bad. So these are the different JSON structures we need to create. So we just connect to the server, we give it a username. So I just made a bunch of functions that return the JSON blobs. So we have the dictionaries that then can be converted into JSON blobs. So we have the register function, the bet function, the get proof function, and the get flag function. So it's not too bad. First we do a json.dumps, we register a user, we get the response, we bet. I'm betting 999 times 99 times -1, so a very large minus number. We'll get the response, and then we're going to ask for the proof. We read out the proof, and then we just ask for the flag. And if the server's still live, this should just work. Cool, and yep, it worked. So we sent out, it told us we lost. We guessed a value of -1, which would obviously never be true. And then we do minus this large number. And this is our current balance, a very large number. And we can see that this has a bit length way greater than the byte length of this. So cool, we get the flag. So pretty simple challenge. Next was Casino 2. I think this was my favorite challenge from the CTF. If you do a diff between, actually let's go look at what it says. Casino 2. Definitely crypto. The last one said not crypto. This one has way less solves. And we're given a file. So if we download the file and we do a diff between the old directory and the new directory, there's only one change. I think it's in casino bet. Where's the bet function? There we go. This is the only change between the two files. And so now we can no longer do our negative value trick. So this is where things get much more interesting. But if we look at, was it the Docker file? I think we're given a go mod file. And if we specifically start poking around, we're going to look at this IAVL package. So in the previous challenge, there was something about a tree and it was loading values from a tree. So this is a binary tree. I think it's a self-balancing binary tree. So it just means that every node has 2 children and it tries to keep the tree at a consistent height, like a very equal height. And so the tree always looks very balanced and pretty. That's how I think about it. So anyways, we have this tree structure and it has a specifically pinned version. If we look around, we'll see that this was actually part of a recent exploit. Let's see. Well, actually, let's just, if you Google around, you eventually will find the exploit. There's a better word to search, though. I think it was in the flag seller. It's specifically the range proof is what's broken. Range proof exploit. I think this was the article I ended up relying on a lot. Yep. Cool. So apparently this exploit using the range thing was used a couple of months ago to steal 2 million BNB from the Binance bridge. I think this was like $90 million. And so if you go through this blog post, we're basically recreating the attack that the attacker used. And it has to involve this IAVL tree. And so basically you just need to recreate this exploit. And so what we're going to do is it's possible to trick this validation code. So we pass it a username. So it would be like Conrad, balance of 1,000, and this proof data, which is just some base64 blob. What we're going to do is we need to trick it such that this proof data says that Conrad actually has, some very large amount, because there's no way we're going to win this gambling function. And this is possible because someone else was able to use it to steal, $90 million. So we just need to recreate the attack. And the idea behind the attack is, so like I said, we're sending proofs. So there's things called Merkle trees, and basically you have these giant tree-like structures on these different cryptocurrency things, and they use this structure called a Merkle tree, and basically you create a tree of hashes all the way up, so that when you want to validate if something else is a member of the tree, you don't actually have to hash all the content. You just hash the things that changed, and as long as the top hash matches the changed hash too, you can kind of just guess that whatever node was added just kind of aligns with everything else. Probably wasn't the best explanation, but basically we're just doing hash checks, and we make sure that the root node hash is also valid. And so if we actually look here, so we're given this proof data. What's also passed in but not explicitly passed in is the root. So we're checking the root hash. And so this was actually passed in when this object was created. So they know what the real root hash is of our structure, and we're just sending them some proof. And what they're going to do is they're going to take this proof data, they're going to calculate the hash because of this proof data, and they're going to make sure that it matches up with the real root. So this proof data is actually just a small subsection of the full tree. So like if we only change this path, our proof data would just contain information from over here. Technically it would also contain this hash, but it would just contain these hashes, not the full tree. And so then you can verify that this little section is true, and then you can still ask information about it. You can still say, like, imagine this node was my username, is equal, let's say like Conrad is equal to, 1 trillion coins. Since it's contained in here, this receiving function can also just validate that little thing. So anyways, like I said, there was a bug in how this was implemented. So you can pass a range proof, which will actually validate multiple nodes at the same time. I highly recommend checking out this blog. It was very good at explaining everything, especially this process here. And so basically, I'd recommend just like, I don't think I'm going to even try to explain it, but basically just kind of go through. And the trick is you can kind of mess with the structure, and you can pass 2 children and it won't validate both correctly. And so you can insert a fake node on the side that will eventually be retrieved and used, but it won't actually be validated. And so you're just kind of inserting this fake node. Thankfully, someone wrote a proof of concept. I think this person. Eventually it'll go to some GIST somewhere. And so basically you just copy the GIST wherever it is. Is it this one? Nope. GitHub. Well, somewhere in this long Twitter chain, there is a GIST. maybe it's this one. There we go. So here's an example of the exploit. I think they recreated the real exploit. Basically, you just kind of massage some values around and you can get it to work. And so we can see, again, they're using like the real blockchain sort of values. Our values are much smaller. But you can see they're forging some payload, they're forging some hashes, they're going to insert a new leaf, and then you kind of massage existing proof data and insert this fake node, and then using that, you can bypass the validation. So like I said, we're going to pass a username, we're going to pass a huge balance, we're going to ask for some real proof data, and then we're going to insert a fake node into our proof data that says that Conrad actually has a huge balance. So it'll bypass this range proof, it'll bypass the hashes will match because the new inserted node doesn't actually contribute to the real overall hash. And then when they ask for the balance of Conrad, they're still going to use this proof data, and it's going to have that fake node with Conrad saying it has a whole bunch of coins, and so then we'll pass this check. So overall, pretty fun solution. Forget how I solved it using the Go script. So like I said, I copied that existing script and I just kind of modified it. So it did a couple things. So first I recreated what was in the challenge script. So I copied just line for line anything that had to do with tree. So this is how they created it. This is how they did things. They called this tree.say version. I'm not sure what it does, but it was necessary. Created a bunch of users. It worked best if I had 3, so that way I know the tree has a top node and 2 children node. Then I get a proof for one of the children, and this is the one I start just massaging. So I get the proof data, I look at it, I print some stuff out, and we're given something like this. This is where I start actually forging something, so I'm going to create a new node, and I'm going to name it AAZ, and I want to give it the key is the username, and the value is the amount of coins it has. And so if you go through, you build the structure, and again, you're following that POC here, just these lines, you just massage it for your usage. There's one thing that you have to do, it'll error out. If you stop right here, it'll error out and say that this right node doesn't have the correct hash, but it'll actually, if you run the code, it'll actually tell you what the correct hash is. So then you just set it to the correct hash, you run it, you'll find the real proof hash and the new forged proof have the same root hash, but this one also contains that forged node. And so yeah, you just take all that, you marshal it out to proof data, and a very similar solve script as last time. You just connect, you send it, you register a user, you get a fake proof, you modify the proof, you send it back, you say you have a huge amount, and here's your forged data, and yeah, everything just works, and it prints out the flag. Not sure if it's actually going to work. So I think I massaged this a little bit. Yeah, I changed the script around because I needed something else, but basically just register 3 names, send over this proof data, and the flag pops out. So very, very cool attack. It was fun to see a real world exploit like that. Anyways, that is all of them. I had a lot of fun. Thank you for putting the CTF out.